Hello physicists, in this video we're going to be talking about the geometric addition of vectors. We're going to talk about vector addition. Vector addition. So basically how to add one vector to another. Okay? So vector addition is the addition of two vectors to obtain a new vector. So the addition of two vectors will always yield a new vector, not a scalar. Will always yield a vector. So the easiest case of vector addition is when you have vectors that are equal. So let's say you have a box. And you had two people pulling on it. So these are force vectors, and we'll talk more about forces later on. But let's just say we have two force vectors. F and F, equal sizes, equal magnitudes, equal directions. So the vectors are equal. They have the same magnitude and same direction. So they're both F. Well, we can easily add them together to get a much larger vector, 2F. So in the case when a vector is equal, F plus F equals 2F. Or 2F basically meaning a vector in the same direction as F, but twice the magnitude, all right? F plus F plus F will be equal to 3F. 3F, okay? So on and so forth. So this is the easiest case, when the vectors are completely equal, same direction, same magnitude. Then you can just add them, like how you would add, like terms. Like F plus F plus F is 2F. F plus 2F was 3F. So very, very simple. Okay? When you have a vector F that's the same all around, then you can easily add them together. Now, let's say you had two unequal vectors. So, unequal vectors. And they're in two completely different directions. So, vector A is like this, and vector B is like this. How would you geometrically add vector A plus vector B? In other words, how would you draw the resultant vector, the resulting vector, the vector sum, you would call it, of A and B? How do you draw that? Now, what you would do is something called the tail to tip method. So if this is the tail of a vector and this is the tip, if you consider it using an arrow, visualizing as an arrow, this is the tail, this is the tip, okay? What you do is you would basically drag and drop. So if I had vector A, I'm trying to draw it the best so it looks the same as my original drawing. So if I were to draw vector A, what I can do is drag and drop vector B. And there's a reason why I can do this. It's because the vector where it's drawn has no impact on the vector itself. It's only how long the arrow is and what direction it's facing. So I could drag and drop this vector here, and it would still be equal to vector B. Okay? So by dragging and dropping vector B so that the tail of vector B is on the tip of vector A, you get this over here. Okay? What you can do now is draw a third vector. Okay? From the tail of A to the tip of B. Like this. This vector is the vector sum of A and B. A plus B. Okay? A plus B. This is the vector sum. So A plus B would drag the second vector up to the tip so that the tail of the second vector is up to the tip of the first vector. In that way, when you align it like this, so the tail of the second vector is on the tip of the first vector, you would draw a new vector, its tail originating from the tail vector A, your first vector, and vector B, your second vector. Okay? Now, let's say I did vector B plus vector A. So now we're going to try to see if vector addition is commutative. There's no order to it. You don't have to take it in a specific order. You can flip the terms around. Well, let's try it. Let's see if vector B over here, we drag and drop vector A, try to be kind of, so you can see it's more or less the same. And then if you draw it like this, so that you have B plus A, just visually comparing, you can see that B plus A is equal to A plus B. It's pointing in relatively the same direction, and they have relatively the same magnitude as well. Okay? So we can deduce that A plus B is equal to B plus A. Vector addition is commutative. Now, as you can probably guess by looking at all the drawings, vector A plus vector B, if I were to take the magnitudes, the magnitude of vector A plus the magnitude of vector B is not necessarily equal to the magnitude of vector A plus vector B. Okay, so if I were to take the length of A and the length of B and add them up, you could see kind of clearly that the length of A plus B is a bit less than the sum of the two magnitudes. It's not equal. So do not just assume that the magnitudes of one vector plus the magnitudes of the second vector will equal, when added together, will equal the magnitude of the vector sum. And this tail to tip thing works even for multiple vectors. Okay, so let's say it vector A, vector B, vector C, and vector D. And let's see if we can find A plus B plus C plus D. Okay, so A plus B plus C plus D. What will that equal? So let's draw A first. Now from the tip of A, we're going to draw vector B. And drag and draw vector B such that the tail of B is on the tip of A, and vector C is directly vertical, and we're drawing C such that it is on the tip of B, then D will be to the southwest. And as you can see, I'm going to draw this vector in green so it's a little less red, it's a little less confusing. This red vector is A plus B plus C plus D. Okay, A plus B plus C plus D. Now, if I were to add A and B first, get that resulting vector, and add it to C plus D. So if I could do this vector, the vector sum of A and B, added to C plus D, it will result in the exact same thing. Because vector addition is also associative. It follows the associative property. So basically, if I had 3 vectors, A, B, and C, and this doesn't have to be just 3, but I'm just using 3 as an example. If I have 3 vectors, this is equal to this. That is equal to that. So using properties of vector addition, you can draw reasonable, drawings of vector sums, and that will be very helpful as you begin your physics journey. Thank you all for coming. See you in the next video.